Welcome back to the series. This is where we learn about AI agent building and orchestration with LangGraph, LangChain, and LangSmith. This is the orchestration design we have covered in the last video. This is a pretty linear design. Only conditional edge this one has is to apply a reflection agentic architecture, which basically means one agent's work will be reflected or reviewed by another agent, which is great. But other than that, this workflow is pretty straightforward. Also, our agents here are not very modular and not made of reusable independent components. They're sharing a lot of stuff. Yes, this is a very important architecture to learn nonetheless, but now that we have learned about it, this is time to start on a new modular design. Welcome to our multi-React agent orchestration. This time, our agents will be modular, self-contained, and reusable. And this time, we will have multiple conditional edges, redirecting our workflow in many directions, where multiple modular agents will get their respective job done and reply back to the user in a synchronized pattern, while our main prompt node will always be available to answer general questions. And this time, instead of putting all our work into one video, I've decided to break it down into three. Yes, these three. Part 1, Part 2, and Part 3. Now let me show you what each part is going to cover. Alright, so in the first video, we're going to go ahead and create a simple prompt node or a chatbot node. And then we're going to bring in the weather agent logic, even the conditional edge and everything. At this point, we're going to have everything written in the same module so that we can test everything and establish a POC or proof of concept. Once that proof of concept is established and we see everything is working perfectly, we're going to take this weather agent code completely out and create a separate independent module out of it. And these modules will have their own LLMs, their own tools, and even their own prompt templates, fully self-contained, thus making them modular and reusable. So once we have our module established, we're going to keep everything the same, the conditional routing and everything, so that the graph remains intact. But this time we have to test to verify that everything is working properly. The logic is pretty simple. When user asks something to our prompt node, something that is not picked up by our conditional edge, it's going to go ahead and hit the end node, thus telling the graph that there is nowhere else to go. The flow ends. So our prompt node will answer straight back to our user. But in this case, when the user asks about a weather question, this router or conditional edge will catch it and send the request to our weather agent, and our weather agent will use this tool, get weather tool, prepare the answer, and then it will hit another end node, thus telling it that graph flow ends right here. And then the answer goes straight back to the user. That's about it. So that's how we're going to end our first video, establishing a proof of concept that a modular ReAct agent can work with our base prompt in a graph. Okay, so in the second video, now that we already have our modular agent working synchronously with our prompt node, we will simply bring in another modular agent called financial agent. And this guy will have this tool, get finance tool. Now don't forget that at this point, these tools are very simple testable modules, because at this point, we're not really shooting for functionality. Rather, we're focusing on accuracy. We're trying to make sure that given the same set of circumstances, all our agents are using their tools properly when asked. So once we bring this agent in, we're going to step by step add this guy to our main graph by adding a normal edge, connecting an end node, a conditional edge, connecting this to our prompt node or main graph. And once everything is said and done, we're going to create a simple chatbot to test against the prompt node, the weather agent, and the financial agent, all three at a time, making sure they're working properly. And at this point, we're going to push our financial agent a little bit farther by using different models as LLMs. For example, Llama 3.3, Gemini 2.0, Claude Sonnet, etc., etc., just to make sure how they perform with other models when it comes to tool usage. With that, we will end our video number 2. All right, now let's talk about the third video. In the third video, we're going to bring in our email agent. This is going to be pretty exciting because for the first time, one of our agents will do something real, like sending an email to the outside world. The idea is once the user requests to send an email, that request will be caught by this conditional edge, and this edge will then route the flow to our email agent, and this agent then scan that request and collect the target name from it. With that name, it's going to go ahead and use tool number 1, which is read email from CSV tool, because we're going to have a very simple CSV file with names and emails in there. So it's going to use that name to collect that specific email address for that person. Once that email address is collected, it's going to follow a very specific set of instruction via a custom prompt template, which will let it know how to construct the formatting of that email. And once all those done, this guy will use this final tool, send email tool, to send that email out to that specific email address, and then report back to the user saying, hey, email has been successfully sent. We also have a provision for failure, just in case the user gives a wrong name that does not exist in that CSV file. Our agent will let the user know, hey, name wasn't found, so email couldn't be sent. And similarly, we will have error provisions for our sent email tool that will also be conveyed to our user that, hey, our tool didn't work, or email could not be sent for such and such reason. Now, once we bring that agent in, we're going to independently test it, making sure this thing works. And then we're going to go ahead and add it to our main graph with the end node and the conditional edge. Once all that's said and done, we're going to go ahead and use another chatbot to test the whole thing. Only difference is this time that chatbot will have memory in it to continue a full-on conversation. And this time we're going to test the whole thing against the prompt node, the weather agent, financial agent, and the email agent, the whole enchilada. And with that said, we are ready to get started. All right, so this is where we start. As usual, I'm keeping the installation to a minimum, very simple, LangChain, OpenAI, LangChain community, LangGraph. That's it. And I just installed it, and our current version of LangChain is 0.3.15. and LangGraph is 0.2.67. That's the latest and the greatest, I promise. All right, with that done, this is how I'm loading the API key. This time I'm keeping it very, very simple, not even bringing in those other models, and definitely not LangSmith, but they will all come back in the next video. And once I set up everything, I just have a tiny little block of code here that I use to test if my model's working, and it is. So that being done, let's get started with ReAct Agent in my graph. All right, so we are ready to add our ReAct Agent to our graph. If you're following this series by now, you're quite familiar with all these libraries, type, dict, and annotated, coming from the Python typing library, Chat OpenAI coming from OpenAI, Tool Decorator, which we use to create our tools, coming from LangChain Core Tools, and then from LangGraph, State Graph, and the End Node. And this is a new one, since we're going to use ReAct Agents. So we are bringing in Create ReAct Agent function from our LangGraph pre-built library. And as usual, the add messages reducer function coming in to add messages to our state. Once the imports are here, we just go ahead and define our state by extending the typeDict class. And here our variable will be messages, and we annotate that with a list because it's going to be a list of messages. And our reducer function add messages, keep adding those message strings to our list. So with that, we go to the next step. We initialize our graph builder. Before, you probably saw I always use the name graph, but that's not proper because graph hasn't been built yet. We are just building the graph. Once we compile this graph builder, that's when we get a graph. So I changed the name graph builder properly. And this time we are invoking our state graph class and passing the state data type in there, start the graph builder structure. And as usual, we are using Chat OpenAI model 4.0, GPT 4.0 and temperature 0.5 to create our LLM. With that done, we move to define our prompt nexus node, which is basically our prompt node or chatbot node. And this is the function, very simple, returning all the messages by invoking our LLM with state messages. Basically, this is where all the user conversations come through. We invoke that, and whatever result we get, we return it, building a chatbot using the prompt nexus function. So once the node function is ready, we just use graphbuilder.add node to create our prompt nexus node in our graph using this function. So now that our basic graph is done with the chatbot, we jump on to building a tool for our weather agent. As you saw before, the at tool, this is the decorator we just brought in. As you saw before, the at tool, this is the decorator we brought in from LangGraph. With this decorator, this function turns into a tool. As you can see, get weather, which takes in a city as a string, as an argument, and which is a very simple tool. We are telling it to call this to get the current weather, use this anytime asked about the weather. So it just takes in a string called city, and then if it is Paris, then always returns it's always sunny in Paris. Otherwise, for any other city name, it will always return it's cold and wet. As I mentioned before, accuracy is our target, not functionality. So we kept it so simple that just by looking at our agent's answer, we know that this tool was used. Anything else, any other hanky-panky, we disqualify that answer. We know the tool hasn't been used properly. And of course, next time we're gonna bring in the LangSmith, where we can trace everything, go into detail, and have our proofs. But for now, we're just keeping it simple. So with that tool ready, for the first time, we create our ReAct agent using that function, which takes in our LLM and the tools. This also takes prompt templates, etc., but not in this case. We don't need it. We'll use that in future. But by invoking this function with all that, we finally have our runnable weather agent. And now that we do, we add that agent in our graph by using graphbuilder.add node weather agent. And this time, instead of an invocation function, we just use that runnable we just built using create ReAct agent function. The node has been added. Now we connect it. Now we declare a route to weather function, and this is the function we will use in our conditional edge, which is also very simple. We are just looking for the word weather in our user message, the message.content. We just turned it into lowercase so that we can match no matter what case the word comes in from the user. And once we do, checking through our state messages, if we do find weather, we return weather agent. Now trust me, this part can be a heck of a lot more sophisticated, and we will get there soon, but not in this case. Once again, we're keeping it very simple. So once we check for the weather and it's not there, we go straight to the end node and thus have our router function ready. With that, we go and add our conditional edge with graphbuilder.add conditional edges. We bring in our prompt node, prompt nexus, and use this router function and a data mapping. Basically, this data map maps a node to these variables, making these router functions more dynamic. Now, I'm not gonna say too much about it because I do have a LangGraph 101 series where I talk in detail about this stuff, so please go check that out. So basically what happened here, we just added our conditional edge, thus adding our weather agent to our prompt nexus in our graph. Once that is done, as you know by now that once one conditional edge is added, we have to have another regular edge to that module, redirecting it to somewhere else. So at this point, we just have our weather agent going straight to the end, because at this point, this graph will not flow anywhere else. Once our weather agent gets a question, prepares the answer, it just goes straight back to the user. That's what it means. We end the graph flow right here. Once that's done, we set an entry point, graphbuilder.set entry point prompt nexus. That is our prompt node or chatbot node. That's where everything begins. With that done, we go ahead and compile our graph builder for the first time with graphbuilder.compile, create our graph, and then visualize it. So let's do that. Boom, there you go. This is our new graph, prompt nexus, our prompt node, and our weather agent all working together. So now let's go test it out. All right, so we're gonna do a quick test in here. As mentioned before, we're not trying anything fancy. With our first question here, which is the generic question, we're gonna test our prompt node just to see if our chatbot is okay. And then we're gonna have back-to-back two questions. How's the weather in Paris versus how's the weather in London, just to make sure our weather agent is being invoked and that weather agent is using the right tool to respond. Okay, so let's get started here. As you see, this is our graph, and first question is, who is Donald Trump? Boom, there you go. We have our answer. So that means our chatbot is functioning fine. Now let's ask about the weather. There you go, Paris is sunny. Exactly how we set up our tool. Now let's give it another city, see what it says. The answer should be cold and wet. Only then we know our tool has been used properly. Let's go. Boom. The current weather in London is cold and wet. Bullseye. All right, so our structure is working great. Now what we're gonna do, as I mentioned before, we're gonna take this weather agent, weather ReAct agent out and make it modular, take it to a whole different function, and then go ahead and test the whole thing against both our prompt nexus and the weather agent. Let's do it. All right, so this is gonna be our structure this time. As you can clearly see, weather agent is a separate module than our main graph. And to combine, we're going to go ahead and establish a test chat with our prompt nexus and weather agent. That said, let's look at our weather agent. As you can see, completely independent module. It's bringing its own things, chat OpenAI tool, create ReAct agent. But everything else is the same. But this is a different dedicated function called weather agent, taking in a string as a key argument. These instructions are exactly the same as before. Create our LLM, create our tool, we walk through this, and then we create our ReAct agent by passing the LLM and tools, and then simply return that weather agent. So with this, you can actually see how modular this is. I mean, you can now just cut this guy out and dump it in a Python file separately, and that will become your agent module specifically for this weather agent. And that one you can use anywhere you like. For any other graphs also is going to perform the same function as long as you keep feeding it that city. Now let's just go through our main graph one more time. Usual stuff, the state, the graph builder. It has its own LLM, prompt nexus, that's our prompt node. We're adding that prompt node here. And in here, all we have now is one line, just graph builder.add node, weather agent. Since we did not change any name or anything, that same function will just come in as the node. And we have our usual routing function, kept it exactly the same, and then added exactly the same way. The rest is exactly same, setting the entry point. And this time we're going to just go ahead and compile the graph. And guess what? Find the exact same structure. Now let's go talk to it. Our usual while true based chatbot, where we just simply invoke the graph with the message, and the user input we just select from our prompt that we put in. and the rest is just the simple. So let's just run that. So let's ask some usual question. Who is Sam Altman? And with this, we're gonna test our prompt nexus or chatbot. Boom, get an answer which is accurate. Now let's check the weather. What is the weather in Atlanta? Be cold and wet, and it is. And last but not least, how about the weather? Paris. Check it out. Always be sunny, and it is. And of course, we'll enjoy the sunshine. Say bye and end to it. And this is where my friends have just established a POC or proof of concept that we can bring in modular React agents and keep adding to our graph. And according to the conditional edges, they will be invoked and keep giving us the answers we need, keep doing our tasks, etc., etc. With that, I end this video. Please like and subscribe, and thanks for watching.